Yesterday's exercise, the first one was already balanced, but I told you not to write the coefficients. Okay, so it was like this without the coefficients. I think that in this point, you all know why hydrogen and oxygen here, they are zero, right? The oxidation state, it's zero here because of the rule number 1 that says that on combined elements, the oxidation state is zero. And after, we have the oxidation state for oxygen that is -2, and the rule for hydrogen that is 1. So here I have 1 times 2, 2, -2 is 0. Okay. And from here, you're able to get your redox part. Okay. So hydrogen was 0 and oxygen was 0. After the reaction takes place, oxygen is less, okay, than 0. So the oxidation number is reduced. And in the case of hydrogen, it was increased. So we say that the oxidation number is oxidized. It is oxidized because it was 0 and after it was 1. So we say that it was an increase in the oxidation number. So it is oxidized. It is reduced because it was 0 initially and after the reaction took place is -2. So what happened with the oxidation state? It was reduced. Okay, it was decreased. So we say that is reduction. And just for everyone to have a clear understanding on this, remember that we do the redox part with the half reactions, red being oxygen. And here, one important step. We need to balance because in the reactants, we have 2 oxygens. In the products, we have just 1, okay? So to balance, I need just to put 2 in front of oxygen. We don't forget about the charges. The initial charge was 0 and after was -2. So we are also going to balance these charges. You're gonna do this process whenever you are, whenever you have an atom different from 1, okay? So to balance the charges, okay, you're gonna have 2 from the bottom, 2 from the subscript, okay? And it's going to multiply the charge. And these 2 from the coefficient multiplying the charge. So 2 times 0 gives you 0. And 2 times 2 gives you 4. So how many electrons is the difference between 0 and 4? Here you're going to make an adjustment with 4 electrons because it's reduction. Remember, the electrons are in the reactant. So the 4 electrons are going to be added here in the reactants. In oxidation, we have the half reaction H2 producing H2. H2 has an oxidation state of 0 because it's uncombined, because it's a pure element. And hydrogen is a binary element, so when it's pure, it has 2 atoms. And in the other part, we have hydrogen with a charge of just 1, okay? So to work with the charges, you have 2 as a subscript multiplying the charge of 0. And after the reaction, you have 2 as a subscript multiplying the charge of positive 1. So 2 times 0 gives you 0, and 2 times 1 gives you 2. So how many electrons are you going to add? The difference between 0 and 2. The difference is 2. You're going to write it positive, okay? And Belen, the question that you had before, even if it here the difference is -4, you're going to include the electrons positive, okay? Here we're just finding the difference. We're just finding the difference. We don't write signs, okay? So 0 minus 4 is going to give you -4, but you're going to put it as positive 1 here. Sarah.
So, Miss, what is like the key to identify the reducing and the oxidizing? Because I think that is the one that is getting entangled.
Okay, the key to identify reduction and oxidation is see that, well, to calculate the right oxidation states, to know the rule of oxidation numbers, okay? That's key. Because here, if you just look for the elements and you look
No, but
for the,
I mean for the agents.
for the agents, it's like the just think inversely of what you're doing. So for example, here, the element that is reduced is oxygen. Therefore, oxygen is going to be, it is reduced, okay? Oxygen is reduced. So it's going to be the oxidizing agent. Oxidizing agent.
The reduced is going to be the oxidizing, and the oxidizing going to be the reduced.
Exactly. If you want to memorize it like that, ay, se cerró esta papada. Wait. What did I do? Agent.
Okay, now yes, I got it. Thank you.
Okay. Okay, so here we see the difference. The difference in the charges, the difference is 2. Okay? So the difference is 2. So these 2 electrons, because it's oxidation, we're going to add them in the products. Okay? I'm going to move this aside. Okay. So 2 and 4. I need my electrons to be equal. By what number I need to multiply the second reaction in order to have 4 electrons?
By 2.
Okay, so here. My electrons need to be equal, so I'm going to multiply just the second reaction by 2. Once I do that, I will add everything again. It's gonna give you O2 plus 4 electrons, producing 2O. And in oxidation, gonna give you twice the formula that you had initially. You're gonna have 2H2 producing 2H2 plus 4 electrons. So I'm reading a question that says, why in this process we multiply by 2? I don't know, by what 2 do you mean, Fabiana? By what 2? Do you mean the 2 in front of oxygen over here? Or do you mean these 2 that I just put?
The first one.
Because in half reactions, they are reactions, okay? Whatever you have in the reactant needs to be in the product. So here you have 2 oxygens. Initially, you had only 1 oxygen. Remember that I told you to write the equation without the coefficients, okay? So you need to balance the half reaction. Having 2 oxygens here requires you to have 2 oxygens in the other side. And the only way to have 2 oxygens is when you multiply by a coefficient of 2. Because we cannot put the 2 as just like a subscript, okay? So we always put it as a coefficient. So we multiply times 2. And now, yes, we're going to is that before we didn't do it? Because we didn't actually have to balance because they were already balanced. 1 manganese in each side and 1 sulfur in each side. So to know the difference in the charges, for example, 7 times 1 is going to give you 7. So when you have just 1 as a subscript, to balance the charges is no needed, okay? Because it gives you 1 times 7, 7. And the other side going to give you 1 times 2 is 2. And then you see the difference, but it's the same. 7 minus 2, which is 5. Here, we do it because we have a different amount. So we need to see the charges. We multiply charges by oxidation state. 2 times 0. Charges times oxidation state. I'm the dumbest person. Coefficients or subscripts times oxidation state. So coefficient oxidation state minus 4. There's not always like a definite path, okay? It's gonna be different according to your needs, according to does your exercise need to be balanced? Does your exercise and do you need to cross multiply, or do you just need to find a factor to equalize the number of electrons? I'm trying to explain you in different ways, okay? So you can see different type of situations. Now, there are many possibilities. I mean, as many as chemical reactions. Okay, entonces, here only what you have to do is just to get rid of the electrons. And then you add the equation. Giving you 2H2 plus O2, 2O plus 2H2O, okay? 2H2, sorry. Okay. So you have your coefficients, the 2 and the invisible 1 over here, and the 2 for each in the other side. You copy the main formula. H2 plus O2 equal to H2O. So for H2, I'm gonna put as a coefficient of 2. Guys, sorry, is that my iPad is bugged or something? So I put the coefficient of 2 in front of oxygen. If there's nothing, it's just invisible 1, so I'm not going to include it. And then it says that respectively, both oxygen and hydrogen are going to have 2 as a coefficient. But because I have just one compound, I'm just going to put this 2 over here. The same 2 from here is this 2 that I put over here. And now I need to see if it's balanced. Sometimes it's going to be balanced, some other times it's not going to. Elmer.
Miss, and what happens if I put 0 O2 plus 2H? It's okay, or when
If, for example, if you put it like this,
no, in the when you do the addition,
the first addition or the second addition?
the second.
Can you repeat that question? Because now I'm lost.
If it's okay, that is O2 plus 2H.
O2 plus
2H
2H.
in the reactant.
Oh, yes. O2 plus 2H2 or just
Yes,
H.
H2.
Okay. Then yes, it's okay. You can write it first or second. It doesn't really matter. It's like in math. 3 plus 2 is equal to 2 plus 3. Okay. And then you just verify if it's balanced. I have 2 times 2, which is 4. And in here I have a same. And then I have 1 over here times 2, which is 2. And over here, I just have 2 as a subscript. And you can see that it is balanced. Okay, so we have this reaction, and the first that I have to do is I will apply the rules of oxidation state. The pure elements, such as copper and silver, they will both are going to be 0. When silver is combined, it's going to have a fixed charge of +1. Okay? Here, copper is going to have the charge of 2. Why? Because when you form the compound, you have copper and you have NO3, and NO3 is nitrate, which has a charge of -1, okay? And copper has the possibility to be copper 2 or copper 1, okay? So because I see that 2 over here, I know that it has to be copper 2, okay? Because if I put just the copper 1, in copper 1, you wouldn't see parentheses, okay? Because you will have this copper 1 with NO3 minus, -1, okay? So they're both are gonna be canceled. And this compound is not the same as this one, so it's the other possibility. So this is copper 2, okay? And I have nitrate. And okay, I want to say something about this. Okay, I want to say something about this. You have NO3, okay? NO3 is a polyatomic ion, which has a charge of -1. So you get the oxidation state, you get nitrogen plus 3 oxygen equals to -1, okay? And you want to know what nitrogen is. So nitrogen is, you get it like that, nitrogen -6 equals -1. So nitrogen is -1 plus 6. So nitrogen is 5. With this, I'm saying that because we have nitrate in both sides, be careful, okay? I'm just talking about when the polyatomic ion is the same. When the polyatomic ion is the same, they're going to have the same oxidation state, okay? So oxygen will be -2, nitrogen will be 5. Here, oxygen is gonna be -2, nitrogen still gonna be 5. Why? Because it's nitrate, okay? So you can do it all the process, but it's going to take longer than that. Just know that if you have nitrate or, for example, sulfate repeated in both sides, so the same, for example, in sulfate, sulfur is going to be 6, both sides. Doesn't matter what is the compound that you have, the oxidation state for the polyatomic ion is going to remain the same. So now that we have found all the oxidation states, we're going to see oxidation and reduction. So first, I'm going to identify reduction. Silver was 1, and after the reaction, it was 0, okay? So initially, silver had 1, and after 0. So that means that the oxidation number was decreased. So therefore, this is red. And remember that in red, the electrons are in the reactants. Bueno. And then in copper, we have copper 0, and after we have copper 2, which means that copper is oxidized. And because it's oxidation, electrons in the products. So you get your red, ox reaction, half reactions, and you have silver 1, and then silver 0. How many electrons I will need to add?
1.
1 electron because it's already balanced, okay? I have 1 silver in each side, so just 1 electron to be balanced. Then in oxidation, you have copper 0, and after you have copper 2. So how many electrons to be added? It's already balanced, okay? How many electrons to be added?
2.
By what number I'm going to multiply the first reaction to have the same number of electrons?
By 2.
And then we add. So you will multiply each. So you're going to have 2 silver plus 2 electrons, producing 2 silver. That is your reduction. Then in your oxidation, you're going to have the same formula. Okay, copper 0 producing copper 2 plus 2 electrons. You can get rid of the electrons directly. You can get rid of the electrons directly. So you will have to add now silver 2 and copper, producing 2 silver and copper. So the coefficient for copper is going to be invisible 1. And then you're going to copy your main equation. And then you're going to balance, okay? So list the elements. Copper, silver are metallic elements, non-metals, and hydrogen and oxygen in the last step. We don't have hydrogen, but we have oxygen. Okay, silver has 2 as a subscript, so I'm going to put it here. This other silver, also 2, so I need to put here in silver at 2. Then I will see. Copper is 1 copper in each side. Silver is 2 in each side. Nitrogen is 2 times 1, which is 2. And in the other side is 2 times 1, which is also 2. Oxygen is 2 and 3, that is 6. And in this one, oxygen is 2 and 3. Make it 6. And with this, we say that is balanced. So in this is another example where you didn't have to do any other adjustment after